Okay, we made it. All right. It looks like we're going to go ahead and get started. Okay, thank you very much for coming out. This is going to be Progressive Web Applications with Angular. My name is Brian Love. You can follow me on Twitter. There's my Twitter handle. I am a Google developer expert in Angular and web technologies. And I'm originally from upstate New York, so I'm from the States. And I tell a lot of people that I'm from New York, and they assume that I'm from this island down on the bottom, and that's not the case. So I'm actually from kind of in the middle of nowhere, and that's where I was born and raised. And I'm currently living in Denver, Colorado. And that's a picture of me and my wife skiing out at Vail, and then a picture of me there. So, okay, so that's not really what you're here to learn about. You're here to learn about progressive web applications. And I'm going to often just refer to this as PWAs, right, for short. So what is a PWA? This is taken directly from the Mozilla developer documentation. So progressive web apps use modern web APIs, right? So we're talking about things like service workers, notifications, and these kinds of things, along with traditional progressive enhancement. And what we mean by progressive enhancement is if your users are using a browser that does not support service workers or these modern APIs, they still get the same experience that you would expect them to get. But if they do support these APIs, we're going to progressively enhance their experience so that way they can take advantage of these things. And it allows us to create cross-platform web applications. So when we mean cross-platform, we're talking about browsers, mobile devices, iOS and Android, as well as desktop. So let's take a quick look at a demo. This is actually one of my favorite PWAs out there. And you can load this up on your desktop if you'd like. It's app.starbucks.com. I'm going to switch over here. Oh, I got to go to full screen. Okay, so you can see here that I have the application open. I get a very rich experience, just like you would expect. But one of the things that's really cool is if we go up in here, and this is just came out in Chrome 73, I believe, about a week ago. And you'll notice that if I scroll down, I know it's a little hard to see here, but now there's a new option for Mac OS users called install, right? And so I can go ahead and install Starbucks. I'm going to get prompted, so I'll go ahead and confirm that and hit install. And now you're going to see that there's an application that's been installed on my device. I can go ahead and launch that just like any other application, right? And here it is. This is Starbucks running as an application on my device, and it feels and looks just like a native application. In fact, you know, I can close it. I can switch between tasks. I can search for it. Oops, start up this Starbucks. So yeah, that's an app, and that was installed just like that. No download, no app store, nothing. I got a couple of screenshots here just in case the internet wasn't working. And so let's get into what PWAs are. And so this is what Google defines as the criteria for a progressive web application. So first, they need to be reliable, fast, and engaging. And when we talk about reliability, what we're talking about is I should be able to use this application whether I'm on a slow 3G network or when I'm offline. It should also be fast. Right? So minimal timed interactivity, that's that TTI that we often hear and talk about. And we want to see that to be very minimal on a slow 3G connection as well. And we want it to be user engaging. So we want that same user experience that you would expect from a native app that you might download and install from an app store. So progressive web applications kind of came out of this paper. I think it was written about 8 years ago, maybe. Don't quote me on that. By these two guys that worked at Google, Alex and Francis Berriman, right? And they came up with this whole idea of web applications should become progressively better, right? So you're already consuming this content today. Maybe you go to Starbucks a lot, and you're like, well, I want a better experience. I want an offline experience, right? How do I make that happen? And so they wrote this paper, and it's entitled Escaping the Tab, Progressive, Not Hybrid. I certainly recommend you check it out if you're looking to read a little bit more about this. Oop, got a bad animation there. So maybe now you're thinking, oh, well, Brian, this sounds cool, man. I like this. But what's the landscape out there like? I mean, can I actually use this today? And the answer is, for the most part, yes. Right? So we've got wide browser support for most of the APIs, and some of them we're going to get into in detail a little bit later on. But Chrome, Firefox, Safari, and Edge all have broad support for the APIs that we're going to be using, as well as mobile, Android, and iOS. And that was a big one, actually. So Safari just released support, I believe, last summer or last fall, and they were kind of one of the last to do that. And then finally, we also have desktop support. So Windows 10 with an Edge browser, you can actually ship your app into the Windows 10 App Store, or you can use Chrome as well, and then Mac OS, as you saw in my demo. Okay, so how do we accomplish this? Let's kind of get a little bit deeper into this. So let's first talk about App Shell, and then we'll get into the Service Worker API. Then we'll talk about the web manifest file that we'll be generating, and then we'll talk about progressive. All right, first is the app shell. So what do we mean by an app shell? An app shell, this is going to be the navigation around your content, right? And we're going to deliver and cache that app shell in the browser before we actually deliver any of the content. Again, that's to reduce that TTI. Service workers are a big part of creating progressive web applications. Service workers enable us to build applications that are offline, right? Applications that you can consume when you're not, connected to the web, maybe you're on a flight or whatever it is, right? Service workers also enable us to do versioning, so we can install and update new versions of our application. Service workers also enable notifications. So these are push notifications. Maybe they're annoying. You can always turn them off or say no, so the user has control over that. And then lastly, service workers are also going to enable background synchronization, right? And so that's still in draft. You can check out some of the proposals that Google and some of the people have out there, but certainly be wary in terms of getting into that, because it's not quite ready for prime time. So let's talk about the life cycle of a service worker. So what's going to happen first is your service worker is going to be installed, right? Once it's installed, we can actually determine that it has been installed, and we'll cache all of those resources that we talked about, like the app shell. And then we'll also get into the activated phase. Once we're in the activated phase, that's after the application has been installed, and now we have an opportunity to maybe clean some stuff up or do some additional work. Finally, our service worker goes into what's called like an idle stage. And during this idle stage, we can actually intercept fetches and messaging. And it's important to note that also during this idle stage, the application can be terminated at any time by the operating system. So there's a couple things to note before we get into the code. So our service worker is actually going to be a JavaScript worker, right? So it does not have any access to the DOM. It executes in the context of this service worker global scope object, and there's several properties that we'll be able to access on that. It also requires HTTPS through TSL or TLS, and you can't do any synchronous requests using service workers. I'm not sure why you would, but you can't. So one of the classes that we're going to be working with is called the cache storage. The cache storage enables us to store cache objects, and these cache objects are going to be pairs of requests and responses, so that way we can cache the data that our application fetches. They're available to the service worker, like I said, via this caches property inside this global scope. And we'll use the open method to access a cache, and then there's also a match method that we can use to determine if a request is in any of the cache objects. The cache class is a storage mechanism, as I said, for request and response pairs. And some of the methods that are included in that include match. So that's going to return a promise that resolves that the request exists in the cache. We'll be able to put things into the cache, and we'll be able to delete things out of the cache. So the important thing to note here is a lot of times people maybe come up to me and they're like, well, Brian, I mean, like, browsers already do caching. Like, what is all this like cache storage stuff, right? So this is much different than the caching of kind of like yesterday, right? So this is fully controlled. So you know what's in the cache, you can delete things out of the cache, and you have full control of the cache. All right, so let's go ahead and get started with registering our service worker. So the first thing we're going to do is, again, we want to be progressive, right? So we want to detect if we have this capability in our browser. So we're going to see if the service worker exists in the navigator. And if it does, we're going to go ahead and invoke that register method. And then we'll pass it the path to our service worker JavaScript file. Once that file is retrieved and downloaded, we are then now in that scope that we talked about, right? So now I'm in a JavaScript worker, so I have no access to the DOM, and this JavaScript is going to be executed immediately as soon as that's downloaded. And what we're going to do here is self is that scope context, and we're going to add an event listener and say, okay, when the application is installed, I want you to go ahead and wait. So we're going to use this method that's called wait until, and that's going to accept a promise, and it's basically going to lock it down so that the application doesn't get like half installed or we end up in some sort of odd state, right? So we're going to use wait until, and then what we're going to do is we're going to go ahead and open our cache, and then once the cache is opened, we're going to go ahead and add all of the content into our cache. And that content in this example is like our favorite icon, maybe the index.html, our CSS, and our JavaScript. The next thing we can do is we can actually add an event listener for fetches, right? So the way this basically works is it's kind of like a man in the middle, but not in a bad way, right? So as the service worker, I can kind of sit in the middle and say, okay, when a request comes in, I can then do something with that. I can say, oh, I've got this stored in cache, here you go. I'm not even going to bother with a request. Or perhaps, let's go out and make that request, and let's put it in cache, and then give it to the user. So here you can see what we're going to do is we're going to respond with, and we're going to check if the resource exists in the cache. If not, we're going to actually do the fetch. Then we're going to cache that resource, and then return the cached resource. So let's take a look at that code. Okay, so here we're using that match method that I talked about. We're going to go ahead and see, okay, do we have this request in our cache? And if we do, let's go ahead and just return that. Otherwise, let's go ahead and make a fetch. We're going to fetch from that request and then get the response back in our promise. We're going to go ahead and then open our cache. We're going to put it in the cache, and then we're going to return that response. And so now what we're doing is again, we're kind of like a man in the middle, right? So we've already loaded our application shell, but now for all the data that's being loaded in our application, we're going to go ahead and we're going to cache it. So that way if the user ever goes offline, I've already got it available. So this is really a good use case for this that I often think of is like a news application. Let's say I'm in the airport and I load up my news app or whatever it is, and it goes out and it makes a bunch of requests and it caches everything for me. Now when I get on the plane, all that data is stored in my cache. I can go ahead and open up my application, and I'm able to see all the content that was cached for the application. Cool. So let's talk about notifications real quick. So here's a very simple example. Let's go ahead and we're going to have a button, let's say, in our DOM. It's going to have an ID of subscribe. And when the user clicks on that, I'm going to go ahead and request permission to perform notifications to the user for this web domain. I will note, and this is my preference, but notice that I put this inside of a click handler. I don't know about you, but it really bothers me when I go to a website. I've never used it, and it's like, all of a sudden it's like, I want to notify you of stuff. It's like, whoa, hold on, we're just friends, man. So you can feel free to do that if you want. There is nothing to prevent you from doing that. Personally, I think it's super annoying. So you may want to have an actual user say, oh, I like the, I want this website to tell me about stuff when things happen. And so you may want to kind of trigger that other than just on the page load. The request permission is going to be a promise as well. So the whole API is very promise heavy, right? Or promisey, if you will. So once that result comes back and the user basically says block or accept or whatever it says in your browser, I can go ahead and get that result, and I say if the user has granted me a permission, now I know I'm good to go. I can go ahead and show some notifications to the user. Okay. Let's talk about the web manifest file. So again, this is kind of part 3 of the 4 parts that we're diving into for creating progressive web apps. So I need to be able to tell the browser, hey, I'm installable, right? And so the way we do that is we create a manifest file. So this is just a subset. There's a couple more options in here. I just kind of didn't want to have to make them all squeeze in. But basically, you provide a name, a description. You have a whole array of objects, of icons, all various sizes, as you can imagine. If you've ever done any like mobile development, you got to have all the different sizes for like retina displays or high density pixels and all that kind of stuff. So you'll provide all of your icons in there. Your start URL, that's basically your entry point to your application. The background color, that's going to be the color when it first loads. It's going to kind of show that background color. There's a couple options for display. Here, this is going to be standalone, so that'll be Chromeless. So you're still running in a browser. Like when I had my Starbucks app up, that's running in Chrome, but there's no Chrome around it, right? There's no navigation buttons. There's no URL or address bar, right? There's a couple other display options. I think like minimal UI is one. You can check the docs and kind of see the various options there. Lastly, or second to last, we provide a scope that says anything outside of this scope, I don't want this to be accessible by my service worker or my progressive web app. And then finally, we provide a theme color. And that theme color basically was that when you saw Starbucks, that's that top color of the Chrome, if you will. If it's in the iOS, that's like the action bar up at the top. And so it kind of allows you to theme your PWA. Okay, now that we've got the file created, the next thing we need to do is we actually need to put this in our head. All right, so in the head element, we're going to have a link tag, and we're going to do rel equals manifest, and then point it to our manifest file. And that's it. Okay, so that was kind of the first half, if you will, of my presentation, where we got to learn about PWAs, what they are, how we build them, kind of in more of an agnostic standpoint. But let's dive into Angular and talk about how Angular supports progressive web applications. So Angular loves PWAs. Angular ships, I believe in Angular 5, they shipped with a service worker module, so 5 and up. And that's installable, and you can use ng-add to add that module. Angular, as you know, is a single-page application, so this fits really well into the model of PWAs. Angular supports things like code splitting, lazy loading, and prefetching. So these things all line up very well with building PWAs. So let's see what that's going to look like. So if I've already got an Angular application, all I need to do is run ng-add, right? So I'm going to run ng-add at Angular/PWA. That's going to install a module for you, the Angular service worker module, as well as wire up your manifest. There's a configuration file, ngsw.json, and a couple other things. It modifies the index.html in order to declare the manifest and these kinds of things. So it makes it real easy to get up and running with a PWA. The next thing we need to do is obviously build our application. So we're going to do an ng build and use the prod flag. And then lastly, as we're developing our progressive web application locally, we're not going to use ng-serve because unfortunately, at least at this time, ng-serve doesn't support PWAs. So you can use any HTTP server that you want. I've installed a quick node module HTTP server. And I'm going to wire that, start that up on port 8080, and I'm going to point that to my dist folder and then to my project name. All right, let's do a demo. Get out of full screen. All right, so all I did here was I did an ng new and installed everything ahead of time. I didn't want to deal with, crashing the plane as we heard about this morning with an npm install or anything like that. So I've got this kind of all installed and ready to go. And you can see here I ran ng-add and it added some default icons for me. Can you guys see that? Is that big enough? Yeah? A little bit bigger? Is everybody awake? Are you just waiting on the beer?
Maybe a bit bigger because of the contrast.
Yeah. How's that? Cool. Yeah, so we can see here's our configuration file that I mentioned, the ngsw config. And we're going to talk about some of these configuration options here in a second. Let's see. Here's my index.html file. We can see that it's added in the manifest for us, the link tag there. And the only other thing that I've done is I've injected this class that we're going to learn about here in a second called SW update, and I'm just accessing that is enabled property on that class. So pretty basic. And let's go ahead and load this up in the browser. Okay, so the first thing you're going to notice is underneath the application tab. Oh, let me zoom this up for you. Cool. So underneath the application tab, we've got service workers here, and you can see that my service worker was installed. You can also unregister it if you need to while you're developing and these kinds of things. And then if we go over to the network tab and reload this, you're going to notice that these files were cached, right? And so it's saying that these files came from the service worker rather than being fetched, right? And just to kind of show you that maybe the first time around, let me open up a new incognito window. Let's open up this. Let's go to the URL. Yeah, okay. So we can see here, these files are actually being fetched, right, from my local host. And then upon subsequent requests, you can see now they're being shipped out of the cache. So pretty cool. So what exactly is cached, right? And this is all configured in the ngsw config.json. So by default, out of the box, when you ng add the PWA module for Angular, we're going to cache our HTML file. So that's the index.html. We're going to cache our fave icon, and then we're going to cache all of our JavaScript and CSS that's generated by Webpack. We're also going to cache any files that you have in the assets directory, as well as any resource URLs that you can specify. And those are completely customizable, and you can add resource URLs as your application needs. So there's a couple of different options when you're kind of configuring your progressive web app in Angular, right? So there's two installation modes. The first one is prefetch. This ensures that the resources are available when it's offline. So what's going to happen here is once the PWA is installed, we're going to go out and prefetch all of those resources that we just talked about, and then we'll actually display the application to the user. The other option for the installation is the lazy mode. In this in this mode, we're going to go ahead and we're going to only cache those resources when they're requested, right? So it's kind of like a just-in-time caching strategy in terms of the installation. We can also do versions when it comes to service workers in our Angular application. So we can serve the application from our cache, and then we'll be able to check for new versions every time that application is loaded up. Right? And so what that's going to do is it's going to look at the SHA, basically. It's going to say, what's that hash? And if it's a new hash, then it's say, okay, there's a new version for this. We'll go ahead and fetch that new version of our application. So it's very transparent to the user. This is not like applications in the App Store where you have to go and say, hit update or something like that, right? This is going to happen behind the scenes. We're going to go ahead and fetch those new resources for our application. And then the new version will be launched the next time, or loaded, excuse me, the next time we launch. The other option is we do have full control over that. If we want to, we can programmatically install the new version immediately and reload the application. When it comes to the application update modes, requests that are cached, there's two strategies here as well, and these are configurable in that ngsw config.json. We can prefetch, again, so when there's an update, we can go ahead and download and cache everything immediately, so that way it's ready to go. The other option, of course, is to do lazy as well, so we can wait until those requests are made, and then we'll go ahead and cache them. Keep in mind, though, if you use the lazy update mode, you've also got to be using the lazy installation mode. So you can't do prefetch in one and lazy on the other. Okay. We saw this briefly in my demo. So this is the SW update class. So this is an injectable service that comes with the service worker module in Angular. And this gives us a couple of hooks into our application, into our PWA. right? So we can see if an update is available. We can subscribe to that observable stream, and every time an update is available and Angular recognizes that, we could be notified of that and do some sort of action. We can also subscribe to the observable for the activated, and we can know when an update has actually been activated. Perhaps we want to notify the user, we want to go out and do some additional requests or something like that. We can determine if the service worker is enabled, and that's just a Boolean, true or false. We can also check for updates, so I can manually trigger that update process if I want to as well, rather than relying on Angular to look at the differences in the hash. And I can also manually, as I said, activate an update. So if I know that an update is available, I can go ahead and manually activate that update and then reload the application. All right, there's a couple more configuration options that we have for data requests. We can basically set the number of cache requests, we can set the max age of cache requests, and we can set timeout for requests, right? So these are the content requests that we're doing that man in the middle on, right? And I can say, you know, I only want to hold on to so many, or again, if it's a news application, I only want to hold on to this until some sort of, lifespan, or age has been, right, until we get to that point. It's like, yeah, I don't care about that anymore. Go ahead and do a new fetch, right? So we don't want the news to be stale in our application. The other thing we could do is set a timeout. That's the max time that we're going to wait for requests. And that kind of gets into this last part here with a strategy, right? So we have two options when dealing with a strategy for our data requests. We can use performance, and performance is the default. And what will happen there is every time a request is made or a fetch is made, we're going to go ahead and use the cached version first. So if you remember back to that vanilla JS, if you recall that I showed how we kind of intercepted the request and then we fetched it and all that kind of stuff, this is all built in. So you're not writing that code, right? This is built into Angular's PWA support. So you'll be able to set this strategy, and if it's, like I said, if it's performance, we're going to go ahead and just use the cached version first. Or we can say freshness, right? And so that's where I care about this request being fresh if possible, right? And so we'll go ahead and make that fetch, but we'll fail over to the cache if we get to that timeout, right? So that kind of gives us an option of, depends on what kind of category your resource kind of falls into. You know, if it's a news application, that freshness probably matters. But if it's an application where this is not quite as critical, then you can go with that default performance strategy here. Okay, so that's pretty much most of it when it comes to building PWAs with Angular. It's fairly easy to get started with it. Really, there's nothing that really holds you back, right? I mean, so if you're using Angular today, I would certainly recommend that you think about, as a company or as an organization, hey, do our users need to load this every time off the network? Well, no, this is probably not changing that frequently, right? So what if we go ahead and just enable service workers and enable progressive web applications in our apps today, so that way users are getting that minimal TTI, right, and a good user experience. And so the Angular service worker support, it's pretty good, right? It does most of what you're going to need, but you will find that in rare instances that you might run into kind of some roadblocks. And you're like, well, that's great, but the problem is we need to do this, or we got a little bit of extra that we need to put into this. And so that's where, let me just skip ahead real quick. That's where you're going to want to look at another project by Google called Workbox. And Workbox is a much greater feature-rich progressive web application library. It's much more extensive. It has advanced routing and strategies. It comes with its own CLI. It integrates well with Webpack, so you can use this with Angular today. And then it also has a really nice hook for Google Analytics, of course, since it's made by Google. So it'll make it real easy for you to hook in analytics into your PWA, even if your users are offline. Another tip, you want to make sure that you're not caching anything, that you're not caching your service worker file. So that sw.js file, you don't want to cache that ever. Right? You want to always make sure that's requested. So that way the user's getting that file every single time. You'll run into really some odd bugs and stuff, so make sure that If you don't have control over your server, make sure that you're sending this HTTP header response with max age equals 0. So that way the browser, like the old school caching, right, that's not going to cache the files. That way we're always getting a new one. Because you can get into some rare, like, sticky situations where if a user has a cached version of your service worker, you almost kind of like lose control over it because you can't install new versions or modify the application. So make sure that you do this before you get started with service workers and progressive web apps. The last thing I want to mention is Lighthouse. If you're not familiar with this, this is a Chrome DevTools. It's also an extension in Chrome, and there's also a CLI, so you can integrate it with your CI pipeline. And it's really great. It allows you to have insight into what you're doing and how well you're supporting progressive web apps. It's very easy to run. You throw in your URL, or if it's right in the extension, you just hit run. I believe it ships by default now in Chrome. So definitely use that as a tool to make sure that you're kind of lining up with the spec and that you are doing your best to build a progressive web app that's supported by Chrome as well as a broad set of browsers. That also comes, I mentioned, with the CI/CD pipeline integration, so you can have that as part of your development process. And there's also web app performance and the service worker checklist, so it's a great tool to use. Okay, so looking forward, as it stands today, support for progressive web apps is pretty darn good. I've given this talk a couple times over the last year, and it's actually kind of fun updating this slide every time as we get better and better and better. So like I mentioned, Chrome 73, that shipped, I believe, about a week ago, and that now has support for installing progressive web applications on Mac OS, as you saw me do. Safari and iOS, last year, they shipped support. That's a big thing. Safari was kind of the last stick in the mud on that, so it was great to see them get on board with it. Edge also is supporting progressive web applications with Windows 10. You actually have to deploy that. The way it stands today, I don't know if they're going to change this, but you actually have to deploy that application through the Windows App Store. But that will run in Edge as a native application on Windows 10. There's also some really exciting things coming down the pipeline in terms of streams. So that's going to be native support for things like buffering and bringing streams of data down into your application. You could check out that as well online, kind of see the progress that they're making on that. And then I already mentioned the background sync. That's where we're going to be able to, in the background, go ahead and sync application, while the application is idle, right? So the user doesn't have it up in front, right? As it's kind of like still running in the background on their phone or on their desktop. We can go ahead and still make requests and synchronize data back and forth. I believe that's supported in Chrome today. And there's, I think Firefox, it's in development. Edge has indicated that they're not going to start development on it yet, though they might kind of get pushed as we get further into this. And Safari as well is not in development. Great. That's all I have. If you have any questions, I'd love to chat with you afterwards. Thank you very much. Yeah, let me reiterate the question just so everybody heard it. So the question is, how long does the cache last and when does it get deleted? So it's kind of up to the browsers, right? That's one of those games. But in general, the cache will last until the user manually clears the application cache. And that's not like the traditional like clear all my cache and stuff. They actually have to go into the application tab and delete it in there using the developer tools. So it's really based on how much. I think Chrome uses some sort of formula, if I recall. So it's based on how much system memory you have and all this kind of stuff. And then it'll actually start purging cache on a last in, first out basis, right? So in LIFO, right? So if you're kind of,
the user hasn't used your application in 2 years or whatever it's been, and it kind of reaches that magic threshold and says, I need to start dumping stuff, then it'll start dumping stuff out of the cache for you. But it's pretty predictable. I mean, it's there. I haven't had any issues with the PWAs that I've been developing where the cache just all of a sudden, like, poof, it's gone, right? So this is much more reliable than the traditional cache that you might be thinking of, where, you know, the browser is just kind of caching things and assets. So, cool. Yeah, go ahead, man.
So, like, in terms of like startup performance, you said like, okay, it's cached, and then we have like this old style browser cache.
Yeah.
Cache stuff. So, does the service worker, like, addition to that, like that we get the file immediately, have some like other performance improvements that they maybe store like some like bytecode representation of that JavaScript, or it still has to be parsed?
Ooh, that's a good question, Tomas. I don't want to speak incorrect. So the question was around, so once it's cached, does the JavaScript virtual machine still need to execute it, or does it store it in some sort of like Java bytecode-ish type thing where it can execute it immediately?
It's kind of the same between the browser and the service worker in terms of cache. Like, okay, I get it immediately.
Right. Yeah, you know, my guess is, and this is a guess, I think it still has to be, you know, compiled and executed, right? I don't think that it can store it in any sort of like byte format. But maybe we should Google that afterwards and just double check, because I don't want to be wrong. Yeah, no, that would be cool. I don't know. I don't want to say anything incorrect. So, okay. All right, good. Well, then we can Google it and hang out and have a beer. Awesome. Yeah.
Does the service worker have its own resources, memory, and so on, or is it sharing it with the event loop and the rest of?
Yeah. So it's a JavaScript worker. So it's going to be it's not going to share those resources, not on the main thread, right? So I mean, it's a JavaScript worker, just like we have web workers today, right? And so it's kind of executing in its own context. Cool. Another one in the. Yeah, can I run background code? And I assume you mean like background code, like the app is still up on the device, right? So,
For example, a music player, which is in the background, and just the next track is fetched.
you know, that's kind of a good question. So the question is, can you run kind of, if the application's in the background, can you continue to run that JavaScript code? You know, I haven't had a need to do so. So that's something that, you know, I don't want to be wrong about it, but I don't think so. I think at some point, once it kind of goes into the background, it kind of gets queued up. But again, I'd have to double check that. That's a good question. I know the background sync API is still very much in draft form. And you can do some stuff with it. Like I said, you can start playing with it in Chrome today. And so that might be an opportunity. But that's mostly for doing fetching, you know, asynchronous fetching in the background. But actually running the code while it's in the background, you know, it probably depends on the device and the operating system. Like maybe Edge has one thing and Chrome has another kind of implementation there. So you gotta kind of look at the docs and make sure you're doing it right. So. Awesome. Well, if there's no other questions, let's go get some beer. Thank you.